Okay, now we're looking at reference angles, and so a couple things I really want to point out looking at this is in this first case. So notice here's angle t and here's angle alpha. So sine of t will be the same as sine of alpha. Why? Because they're both on the positive side for y. Y is positive in both of these. So meaning sine is positive in the first quadrant and this quadrant over here, the second quadrant. Sine is going to produce positive values if the angle is in these two quadrants. Now, cosine, however, so cosine, if it's positive here, over in this one, it's going to be negative because you see x is negative on this side, and cosine of t, or in this case alpha, is a negative value when you're in that second quadrant. Now over here, think about beta, and so our cosine of this beta, so notice this is x is positive over here, so for either location, so cosine is going to be positive on beta, but sine's now below the x-axis, so it's going to be negative, and that's what this little reference thing is talking about. Now this isn't quite to reference angles, but this helps us set up what's going on with reference angles so that the reference angle may be positive in one quadrant but negative in a different quadrant. And it's just important to realize that. Realize that if it's above the x-axis, sine is going to be positive. If it's below the x-axis, sine is negative. If it's to the right of the y-axis, cosine is positive. If it's to the left of the x-axis or the y-axis, then the cosine is negative. So, okay, I feel like I belabored that point a little bit. Recall that an angle's reference angle is the acute angle t formed by the terminal side of the angle t and the horizontal axis. So these are going to be acute angles, so that's 0 to 90, not inclusive of 90, because that would be a right angle. A reference angle is always an angle between 0 and 90, or 0 and pi over 2 radians. As we can see, for any angle in quadrants 2, 3, or 4, there's a reference angle in quadrant 1. So if this is our t, so here's t, here's the angle over here, and so the reference angle is this angle there. It's smaller. It's an acute angle. We call it t prime. So again, if here's our t, then here's t prime. And we could, if we know what it is in the first quadrant, we can use, okay, is it positive or negative, and then decide for the second, for the whatever quadrant it's going to be in. Again, here's our t, comes around to here. Here's t prime. Again, is that smaller angle. And so we're showing how to calculate that. So in this quadrant 2 case, we take pi minus t to give us t prime, or we do 180 minus t to get t prime, and that's for the degree versus radians. And then in this case here, we're going to be going t minus pi or t minus 180, because now we're looking how far past 180 or how far past pi has it come. And this next case is not quite making it to 2 pi, so it's 2 pi minus t to get that difference, or 360 minus t, because it hasn't quite made it. So I didn't really talk about it in the second quadrant. Hasn't quite made it to this x-axis, which is at pi or 180. So that's why it's going to be pi minus that or 180 minus that. So pi comma 180. This is actually, we're concerned over here about 2 pi or 360. Okay, let's keep going with this. How to find a reference angle given the angle between 0 and 2 pi. An angle in the first quadrant is its own reference angle. For an angle in the second or third quadrant, the reference angle is either the absolute value of pi minus t or 180 minus t. So absolute value meaning it'll be positive because your reference angle is always going to be positive. So if it's third quadrant, I mean pi minus what's it going to say, 3 pi over 4. No, that's not going to be it. 4 pi over 3. That'd be a negative pi over 3, but the absolute value makes it positive. So this is a nice handy thing to kind of condense out, not having too many rules. For an angle that's in the fourth quadrant, it's going to be 2 pi minus t or 360 minus t. So we kind of showed you that in that diagram. If an angle is less than 0 or greater than 2 pi, add or subtract 2 pi as many times as needed to find the equivalent angle between 0 and 2 pi. So find the reference angle of 225 degrees. So we're going to do, as the rule says, it's third quadrant. We're going to do the absolute value of 180 degrees minus 225 degrees. And so that's going to be absolute value of negative 45 degrees, which is 45 degrees. So this is 45 degrees. That would be our, we don't really have a name for this, but I guess we'll just call it T prime. Use reference angles to find cosine and sine. So angles have cosines and sines and the same absolute value, with the same absolute value as their reference angle. The sign, positive or negative, can be determined from the quadrant of the angle. So how to find? Then we determine the values of cosine and sine, the reference angles. Hope I didn't repeat myself because I got a phone call there. Give the cosine the same sign as the x values in the quadrant. So if x is positive, it's positive, negative is negative. And they give the sine the same value as the y values in the quadrant. So here we go. Using a reference angle, find the exact values of cosine 150 degrees and sine 150 degrees. And I always like the visual of this, so I'm going to draw it here. 150 is right around this, just approximately. So you can see by that, sine of 150 is going to be positive, but cosine of 150 is going to be negative. And what is our reference angle? Well, what is 180 degrees minus 150 degrees? It's going to be 30 degrees. So that this is 30 degrees. So what I'm trying to say here is that sine of 150 degrees will be the same as sine of 30 degrees, which is going to be 1/2. From a previous video, we talked about those different special angles. Cosine of 150 degrees is going to be the opposite of cosine of 30 degrees, which is going to be negative square root of 3 over 2. Again, negative because it's in the second quadrant where x values are negative there. Now it says use reference angles, find cosine of 5 pi over 4 and sine of pi over 4. Okay, so 5 pi over 4 is down here. And so let's get a reference angle. So 5 pi over 4 minus pi is going to be pi over 4. So our reference angle is pi over 4. Now, think about this. In this quadrant, cosine is going to be negative, sine is negative. They're both negative. X and y are negative down there. So sine of 5 pi over 4 is going to be the negative of sine of pi over 4, which is then going to be negative square root of 2 over 2. Cosine of 5 pi over 4 is going to be the negative of cosine of pi over 4, which is negative square root of 2 over 2. Fun stuff. Okay, using reference angles to find coordinates. So this is a very busy chart, lots of information here. It's something you will want to memorize, but I want to just stress a key thing here. If you memorize things from the first quadrant, you can see where the reference angles are in the second, third, and fourth quadrants. And notice these values, so 30 and pi over 6, square root of 3 over 2, 1/2. Oh, look at that, negative square root of 3 over 2, 1/2. That makes sense because x is negative over there, but the y is positive. Square root of 2 over 2, square root of 2 over 2, square root of 2 over negative square root of 2 over 2, square root of 2 over... Oh, that makes sense because x is negative, y is positive, and so on. So these numbers are the same in general, except we have to change the signs. And then down here, these are for these standard angles where the reference angles all refer back to the first quadrant. So here they're both negative in each case, and here the y's are negative. So just be aware of this kind of chart. It wouldn't hurt to copy this down, screenshot it, I don't know, copy and paste it into some other document, but just to keep track of these values. That could be very helpful. So how to find the x, y coordinates of a point given the angle. of a point on a circle with radius of the circle. Find the reference angle by measuring the smallest angle to the x-axis. I don't know if you can hear my cat or not. Find the cosine and sine of the reference angle and determine the appropriate signs for x and y in the given quadrant. So find the coordinates of the point on the unit circle at an angle 5 pi over 3. Okay, so we would do, so 5 pi over 3, by the way, is going to be over here. And this is a rough drawing by hand. So we're looking at that. So if we look at 2 pi minus 5 pi over 3, that's going to be pi over 3. So that's a reference angle is pi over 3. Okay, so if we look at sine of 5 pi over 3, it's going to be the negative of sine of pi over 3 because sine's negative down there because it's below the x-axis. So that's going to be negative square root of 3 over 2. Cosine of 5 pi over 3 is going to be equal to, now that's just going to be cosine of pi over 3. It's not negative because we're on the right side of the y-axis, so that's just going to be 1/2. So this will be located at 1/2 comma negative square root of 3 over 2. Okay, and that's it for that problem. And this section, so that's cool. Have fun with that homework.